Hi everyone, and welcome to another maths video by Maths with Sarah. Today we're going to be looking at this question. It's from an AQA higher GCSE Maths paper. It's from paper 2, so you are allowed to use a calculator. And as quite often is the case with these videos, it's question 26. So it comes from right at the end of the paper where we're looking at the grade 9 A-star type question. So it's a bit of a challenge. But as long as you remember a few key things, there's absolutely nothing that makes this question particularly difficult. So the question gives you an equation of a curve, and we can tell that it's a curve because we've got a quadratic in there, and we've also been given the equation of a line. And the question asks us to show that the curve and the line have exactly one point of intersection. So as normal for a lot of these questions, there are as many different ways of doing this as there are people. You can do it so many different ways. We can either do it by drawing a graph. Say, for example, if you draw this, you might have the curve going like this and your line going across like this, and then you can see that there's only going to be one point of intersection. That will be one way of doing it. However, it does specifically say that it doesn't want you to use a graphical method. So what we need to remember is the other ways of doing this style of questions. So as with all of these questions, I would encourage you to pause the video at some point now and have a go at this question yourself before I walk you through the answer. So even if you don't feel like you can fully get to the answer, at least have a think about what methods you could use to solve this. So as I've already said, you could use a graphical method, but the question specifically asks you not to use that. Okay, so hopefully you've all had a chance to have a little look at how you might solve this question. So what we need to remember is that when you've got two, if we've got a curve and a line, and we know that we've got points of intersection, these points here are the points where x and y are the same value. So y in this is the same as y in this, x is the same as x in this equation. And that means that rather than using a graphical equation, we can use simultaneous equations to find the point where both x and y are the same. So to do this, again, as I've said, there are multiple ways of doing this question. You can substitute in various places. You can find what x is, substitute that in for y. It's up to you how you want to, find an equation for x and substitute that in here. The way that I'm going to do it is I'm just going to set these two equations equal to each other and then go about solving it from there. So if we do that, we end up with 4x squared plus 5x plus 3. And because we know that the y value is going to be the same, we can then solve this, set this equal to x plus 2. So now the best way of doing this is to set this to generate one quadratic equation that's equal to 0. So if we do that, we can subtract an x from both sides. So we'll have 4x squared. If we minus x from both sides, we're going to end up with plus 4x. And then if we subtract 2 from both sides, we're going to end up with plus 1, and that is equal to 0. So now we've got one equation, one quadratic equation that is set equal to 0, and now hopefully you see that we can go about solving this. So again, as I said, when it comes to quadratics, there are so many different ways of solving this. You could factorize it and put it into brackets. Not 100% sure whether this one will go that nicely, but you can give that a go. You can use a quadratic equation, or you can use completing the square. So I personally use completing the square to solve this equation. So I firstly took this part here, and I said, well, if I put it into brackets, I'll get 2x plus 1 squared. If I multiply this out, you're going to end up with 4x squared plus 2x, so that will be plus 4x. And then we'll end up with plus 1 on the end. So obviously this bit here is the same as the bit that we want here. And then we need to subtract 1 because we've got an additional 1 that's generated from these brackets. Here we've got another the +1 that we already had, and that's equal to 0. Now, hopefully you're realizing that we've got a +1 minus 1, so we can just cancel those out. So what we've ended up with now is 2x plus 1 squared is equal to 0. So if we're then going to solve this equation, what we would do is we would say we've got 2 brackets here. We'll set each of them equal to 0 in turn, and that will give us the 2x values for the points of intersection. Now, what you realise is that both of those will be the same. So because we've only got 1 bracket and that's squared, what we're actually going to end up with is one value that says 2x plus 1 equals 0. And we can solve that to find that x equals minus a half. Now, that is the only root we've got. We've only got one root because we've only got 1 bracket here. So therefore, we know that we can only possibly have 1 point of intersection because there's only one position where the x values of both of these curves are equal. We could then work out what the y value would be, but we don't need to. All we need to do is show that the curve and the line have 1 point of intersection. And this is the 1 point of intersection. We know that because this is only 1 bracket here, we know that this x value here, we've only got 1 of them. Therefore, we've only got 1 point of intersection. So hopefully that made sense to you. Hopefully you understood that and you will be able to work through this. So I think the key parts of this question are realizing that if you're looking for points of intersection between a curve and a line, the easiest way to do it is to set the two y values or use them as simultaneous equations and solve them. And that's what we've done here. We found one root and therefore 1 point of intersection. So thank you very much for watching. If you've got any particular questions or topics that you would like to see me cover, please just drop me a message or drop me a comment in the below the video. And I'd also really like it if you would like and share the videos so that other people can see them too. Thank you very much for watching.